Okay. Hello, welcome to my channel. We will read question number 17, chapter 1, mechanics. This is the last question of this exercise. Okay, so this question statement is quite long, but the question is easy. You see, in the big, this is the velocity time graph for a particle's movement shown here. Okay, you can see that, okay, it was moving on a straight line. Let me change the color. I like some exotic colors. Okay, so there was some point, starting point was x, right? But it is moving in the negative, the speed is negative. So it is moving in this direction. So it accelerates first and then deaccelerate and become speed becomes zero again. So it reach over here, okay, and that is the time 2.5 second. Remember, at 2.5 second the speed becomes zero. And after that the streak become positive, so that means after that it will move in this direction, the speed is in this positive direction. Okay, and then it will accelerate for some time and then move with constant speed and then deaccelerate, and it will end its journey at point B. So this is point A. Okay, and it will finish its journey at 14.5 seconds. So anyway, from point A it will go to A, and from A to it will go to B. Okay, so the diagram shows the velocity time graph for a particle P which travels on a straight line AB with V meter per second is the velocity of P at time t second. Okay, so the graph consists of 5 straight line segments: 1, 2, 3, 4, and 5. Okay, the particle starts from rest when t is 0 at point x on the line between A and B and moves towards A. The particle comes to rest at A when time is 2.5 seconds. Okay, so the first part of the question is that given that the distance xa is 4 meter, so from here to here, x to A is 4 meter. Okay, it's going to find the greatest speed reached by P during this stage of this motion. Okay, so basically from 0 to 2.5 second, the distance traveled is 4 meter, right? And that is equal to the area under this curve. So this area is equal to the 4 meter. Okay, and the greatest speed in the negative direction is whatever we want to find out. So let me give this value some name x. So the total area of this triangle is going to be half, and base is 2.5, and height is x, and that is equal to 4 meter. Okay, so from here we conclude that x is equal to 4 times 2 divided by 2.5, and this gives me, and of course this is negative, so I have to put this x should be negative. I can put x is negative. Okay, so this will give me a negative answer, and this answer is negative 3.2, and the units would be meter per second. Okay, so this was easy. Let's change the color. Okay, now the second part of this question, it says, uh, given that the distance x is 4 meter, find the, okay, this will be done. In this second stage, P starts from rest at A. It is rest because at 2.5 seconds the velocity is 0. So when it reaches over here, it stops for a moment. When t is 0 and moves towards B. Now this is with the positive speed. The distance AB is 48 meter. Okay, so distance between A and B is 48 meter. Okay, this is the need piece of information. Okay, the particle takes 12 seconds to travel from A to B and comes to rest at B. For the first 2 seconds of this state, P accelerates at 3 meter per second. So this In this section, the expression was 3 meter per second squared. Reaching a velocity of v meter per second, find the value of v. Now we need to find the value of this v. Okay, so the total area under the curve from 2.5 to 14.5 is 48 meters, right? So let's try to find this total area. The area of this triangle is going to be 1/2, and the base is 4.5 minus 2.5. 4.5 minus 2.5 into V. Okay, this is the area of this triangle. Uh, Let me call this point Y. Okay, now plus I want to find the area of this rectangle. So the base is Y minus 4.5 and the height is V, and plus now I want to find the area of this rectangle or this triangle. So this is going to be half, and base is 14.5 minus Y, and height is V, and this whole thing is equal to 48. Make sense? Let me double check with my calculation. Um, Value of the, okay, sorry. This calculation I had to do in for part 3, but for part 2, it's easy. We just have to find the value of V. Okay, this is easy because we know the acceleration, we know in the start time, we know the end point. So this was very easy. So let me postpone. I will leave it as it is because I will need this thing for part 3. But let me do part 2 here. So this is not part 2. Okay, so part 2, we need to find the V. So for this section of the moment, I will use this equation Vf equals Vi plus At, and here I will say Vf is V, and this is equal to Vi is 0, plus acceleration was 3, and time was 2 seconds. 4.5 minus 2.5 is 2. So this is 6 meter per second. Okay, so this was part 2. We have to find the value of V. Okay, now for part 3, yes, for part 3, the value of t at which P starts to deaccelerate during the state. Yes, so now we have to find the value of y basically. Okay, the y is the time when it starts to deaccelerate. So now I will use this equation, okay, which I wrote over here. So let me repeat this equation here. This is 1 by 2, and 4.5 minus 2.5 is simply 2, and V is 6, okay, plus Y we do not know. So Y minus 4.5 into 6 plus uh, again 1 by 2, and this is 14.5 minus Y into 6, and this whole thing is equal to 48. Okay, so I'm double checking my getting. Okay, this is 6 plus 6Y minus 4.5 times 6 is 27. Okay, this 2 cancel with 3, with the 6 is 3, so it is going to be plus 43.5 and minus 3y and minus 48, or leave it on the equal to 48. Okay, so 6y minus 3y, it is only 3y, And on the right side, I have 48, and then minus 6, and then plus 27, and minus 43.5. Okay, minus 6 plus S1. So this will give me 25.5. So from here, y is equal to 25.5 over 3. So it is giving me 8.5. And the units will be second. Okay. So this is my third part. Okay. And for the final part, the fourth part, the deceleration of P immediately before it reaches B. So deceleration for this part. Okay. So I will use the same equation, this one. Okay. I rearrange it. So acceleration is Vf minus Vi over T. So the final speed is 0. Initial speed, it was 6, right? This is 6. And divided by time. You see, this y is 8.5. Okay. So 14.5 minus 8.5. This is, I will write it here, 14.5 minus 8.5. So this is 6. The answer is minus 1 meter per second square. Okay, so the expression in the last section of this movement is minus 1 meter per second square. Okay, I hope you enjoyed this solution. Thank you very much for watching. See you in the next video.